In this video, we're gonna go deeper into organizing C++ code. So we're gonna create functions for the code that we already have, and we're gonna start splitting the code into multiple files so that it's cleaner and it start resembling what you would have in an actual C++ project or what you would find in an Unreal project. Let's get started. Now let's talk about functions. So if you've done some other programming before, or if you come from Unity, you've seen function, you've used function, the start function, the update function, everything like that. And now we're going to see like how these translate into a pure C++ project. So main is a function. This is, as I said in a previous video, an entry point. So it's a special function that the program is looking for to execute to start the program. So right now what we'd like to do is refactor what we have here so that our game is a little bit more easy to work with, and that we can kind of reuse some of the stuff that we created here. Like the place, like just this, which just gets a player choice. So this is exactly a good example of a function we'll want to create. So to talk about function, we're going to talk about some little concept like the compiler, and I'm not going to go too in depth right now with these subject. Well, I'm just going to teach you kind of what's necessary, and then further down the road we're going to have a little bit more of an in-depth video on the stages of compiling, pre-processing, and linking. But for now, I'm just going to give you what you need to know. Okay, so the first thing you need to know actually are the stages. So as I named it, there's a preprocessor, there's a compiler, and then there's the linker. So what the preprocessor does is looks for these hashtags. There's a couple that you can have. There's include, which is the one you're going to use the most. There's define that lets you define something. So let's say here I do it's like a constant number of cases, and I put 1. I can use number of cases somewhere, and the job of the preprocessor is literally is going to copy paste the value everywhere you can find this name. Okay, so whenever you compile, this is going to be replaced to the value here. In the compiling video, we're going to show you the output a little more, but for now that's what you need to know. So there's define, there's a couple more, but for now, like the one we want to look at is the include. So the include preprocessor, that's the first thing. Like when you compile, before the compiler runs, it's gonna replace wherever you put include, it's gonna replace with the content of that file. Okay, so it's gonna go in that file, it's gonna copy paste this right here, and then it's gonna read that, it's gonna find include valcore, it's gonna go right here, gonna do this, gonna go back in there and do that. And that's what this include does. So it includes the content of that file into this file, because the next step, the compiler, what the compiler does is it's going to look at the syntax of your file to see if you made a syntax error. And the type of syntax he's looking for is the basic syntax, like you're missing like an end of line here like this, or you are using something that he doesn't know in the context of that file. So the reason why we could put string is that includes string, copy pasted everything in there and put it here. That's what the preprocessor does. So that's the first stage. The second stage is then, compiling for the errors. And after that, it's going to be linking. And that's where, like, when we check at these functions, those concepts are going to be important. So for the functions, since, as I said, if I want to use here a function called print header, like this, and I want it to actually print this, the compiler, when he goes from top to bottom, when he reads that line, he needs to know what this is. Okay, and that's why you cannot do this. I cannot do here, go after main and do void print header, and then do this, okay? You're going to get a compiler error. So we're going to do this. You can right click on your project and do build, or you can in fact just do I think it's Control F7, and it's only gonna do the compiling stage, okay, the preprocessor and compiling stage, but it's not gonna do the linking. And you're gonna get an error, print header identifier not found, and that's because he read from top to bottom, and when he reached that, he hasn't ever read that there was a print header function existing that has no parameter and a void return, okay? And that is important. So then if I take this and I put it on top here, oh, sorry, the copy paste went wrong. If I cut it and put it up top here, and I do again, just the compile stage, I get no errors because he's gonna read this, he's gonna say, oh, wait, okay, there's a print header function, cool. And then he's going to go here and he's going to say, oh, you're using the print header, but I already know about it because you told me here. So that's one concept. So let's start by refactoring our code using this method. So here we have the print header. So if I run here, you're going to see I get the same thing. So now let's do the same for the other function, and at the same time, like, let's clean the code to make some clean functions. Let's start with that. Here, we're gonna cut this. We're gonna do, we're gonna keep that, in fact, but we want to do this. This is like a really, I don't think I would do this function in real life, but you know what? Get player choice. We are practicing doing function, and then we're gonna return. Oh yeah, I need to define this. Yeah, in fact, I'm gonna. Yeah, this is really not a great function, and we're gonna see how we can optimize these kind of things later. But for now, let's go with that. We're gonna return that case choice. So then now we can use that function here to initialize our string. So that's great. I'm missing this. Bracket for function goes on the other line. Did I do it here? No, there we go. That's how I'm gonna see for code style a little bit. So okay, we use that. Now we have this thing that we would need to refactor. So this is doing actually two things. First, it's kind of printing like the phrase that is specific to that case, and after that, it's kind of populating the list of suspects. So we're gonna use this to kind of make sure we split those into two functions. So we're gonna do one that is void. Print, let's say scenario, scenario header. Let's do this. It's a void, and it's going to take a string, which is the case choice, and then we can do that. And then we're going to do another function for the populate of the suspect list. So we're going to do, in fact, we can do a vector of string and say get suspects list. And then what it's gonna do is it's gonna do a vector and then do this minus the cout part. So let's go like this so that we can remove in the print scenario header, we can remove what we copy pasted for the suspect list, because that doesn't really belong to a print scenario header function. So here in the get suspect list, it's the same, it's a reverse. We want to remove the cout here, remove the cout and remove the cout, and we can remove that else because we don't need it here. And then we want to return the suspect list. Okay, now it needs a case choice, which is going to be a parameter, string case choice, that we're going to pass to the function. Okay, so that means we can kind of remove all of this. So we can remove this, and we can instead say print scenario header, and then we can do initialization of this. In fact, suspect list, we can just put that here. Oh yeah, hit once the case choice, and then we can say suspect list equal get suspect list. and then it was the case choice too. Case choice, and here we go. And this is kind of just printing the list. So we're gonna do another function here, void print suspect list. So then it's gonna, yeah, here it needs to go the other line. I'm gonna try to catch myself as much as possible, because usually in other editors it does it, but in Visual Studio it stays there. So it wants the suspect list that we want to iterate through. So vector of string suspect list, and then here we can say print suspect list and pass in the suspect list. Okay. So if we run this, we can start to see, like, does it compile? Yes, it does. And then does it run? Yes. And we have exactly the same output, like we didn't change any of the behavior, but it's just a little bit easier to work with, because now we have functions. So if I wanted to after, then you know the gist of it, like we can reuse those functions. I can decide like, oh I want to reprint the header after the suspect list, and then I'm gonna have like a C suspect list, and then I can reprint the header whenever I want. So this is all good, and this is exactly why we do function. This code is really easier to understand and cleaner. So now that it's better in the main function, we're happy about it. The rest is a little bit weird. Like it's weird to have to be forced to put all these functions at the top of my file with the main, so that the main can compile, right? Well, we don't really have to. There's a way for us to specify this. So the problem with this is the compiler, as I said. Like the compiler reads the file from top to bottom, and if you don't have, and if he hasn't read that print header exists with the specific signature, whenever you use it, he's gonna throw a compiler error. So I'm gonna show you how you can make him happy and not throw errors. So we're gonna move all of this after. Here we go. So if we do Control F7 to compile, we have all our sweet compiler errors. So C, all errors start with C. It's all the same error. It's identifier not found. So the problem is he doesn't know print header. So let's tell him that it exists. There it is. We're gonna do the same thing for all of them. Or let's go with those two. Okay, Control F7 to compile. And then there you go. Now he only complies with the one we don't have here. So let's do the other ones. So print scenario header. I think that player, yeah. Let's do this also because I want to keep that clean. Let's go and copy paste this here. Oh, whoa, I'm lost here. Take this, Control C. There you go. Remove this. Suspect list. Oops, just this. And then the last one, which is the print list. There you go. Control F7. It compiles. So that's what we call a declaration. So whenever you write this without any function body, you actually declare. Okay, so the compiler doesn't care where that thing is. It only cares that you tell him that it exists. You declare that this exists somewhere. This is strictly for the compiler. So that way, when he reads, he says, "Okay, you're telling me that somewhere you have a print header function that returns voids and take no parameter, and it's called print headers." And he goes through the same thing. So whenever he reads it, he knows where it is. And that's basically why you declare some function before you use them. It's to please the compiler. So that way you can have your function be anywhere. Okay, so we're gonna see a little bit more how you would go around and split then that code in multiple files. So right now, if we were to code the whole game into that main function, it would get pretty big pretty fast. So to organize code, we can put these things in multiple files like you would do in any other language or in Unity or anything like that. So the first thing we're going to move is this. So this is declaration. So we're going to use the fact that because it still needs to be before the main function. Like this is not changing. Like whenever he reads the main function, he needs to know about these. So we're going to use the fact that include, copy paste the file to move that into another file. So declaration go into header files. Header files are going to be here. It's .h, and we're going to call it case.h. So in an header file, what you do is you group declaration of types or function that are going to be used together, because since they include copy paste the whole file, you want things that are going to be used. You don't want to here have like a void create infinite world, because whenever we want to get player's choice or print the scenario header, this function is not necessarily going to be used in the same context as these ones. So you wouldn't put this in the same header file as this. So we go here, and then we're going to need the same thing. We're going to need the includes, because again, the compiler compiles every file separately. So that means every file needs to have all the types declared and everything it needs to compile independently. So that means we need to, in fact, we need this. We need this in here because we're using we don't need IOStream, in fact. But we are using string and we are using vector. So if I do control F7 here to compile this file, okay, it doesn't want to do it. Well, I'm gonna compile the project then by doing here, and just you know what, I'm gonna build it. It's gonna say here print header not found, okay, but it had no problem with this because this is compiled separately, so the compiler has no problem. You just put a bunch of declaration in there and he's like, yeah, fine, okay, yeah, I know those one exist, cool. Now what we need to do is use this sweet preprocessor to copy paste that file in here. Case.h. And there we go. Now since we remember this includes, literally is going to grab this and going to put it in here like this. Boop. He's going to do literally this and put it here. Oop, sorry, like this. Boom. He's going to have the print header, the print scenario, the get suspect list, and everything. But there's something like you might notice here, like I include vector and I include vector here. Like it's, isn't it going to be like copied twice? Well, no, it won't, because of that pragma once. So pragma once is going to make sure that those includes only get include once. So if it isn't defined before, he includes it. But if he already read or that header or whatever, he's not gonna repaste it. In the end, he's not gonna include this again. So you're gonna get that. So that's cool. Let's go back because we're not doing the preprocessor's job. We'll let him. This is way more easier for us to work with. So there we go. So if I have this include, now I can build my project and it's going to do the same thing that I was doing before, right? I build it built, and now I can run it. And there you go. If I put C, I still have the list, the knock and everything. So everything is available to me. Now we're going to move some function around. To move the function, I'm just going to cut them here, Control X, so that they're not here anymore, and we're going to create a new file. So there's something that wasn't clear to me whenever I started using Visual Studio. It's that these folders here are not really folders. They are filters, meaning that in fact this file and this file are in the same they are the same folder, right? If you go into your project view here, you're going to see like they are in the same Hello World folder. it's just for you to kind of organize. If you're looking for something, then you can go in the other file. But whenever you actually create, like let's create our new CPP file, you can specify like where you actually want it to be. So right now, oh, you see, I wasn't in the right. In fact, it's in another folder. So here I'm gonna do a CPP file, and it's gonna be called case.cpp. For you, it should be like here, hello world. It's just I've played so much with my my project that I've made a little bit of a mess. But don't worry, yours should be here, hello world. It should be that. So I'm gonna create the case.cpp here, and I'm gonna paste my functions. Here we go. So we have that. Now we still have the same problem. We need the same thing that we've put here because it compiles separately, which means it needs to know about these things, and it needs to know that we're using the namespace std by default. There we go. And since I'm using cout here, I actually need iostream. Include. Wow, I have a hard time typing today. iostream. There it is. Okay. So right now with that, I can build my project. And there's no actual problem. And I can actually run the program with no problem, like it was before. So why is that? If I go in my main.cpp, like, yes, I include the declaration, but I didn't really tell him, like, where are those functions? And that's the next step after the compiling that is taking care of this, the linker. So the linker is the one that's going to look for the actual function. So he's going to look that there's actually function defined there. Okay, but the compiler doesn't care. He doesn't care that it's that the function actually declared, because he knows all the file independently, but he has no concept of the global project. That's the linker's job. The linkers is going to go and find that print header function actually exists and is a valid function, right? And it's also one the thing that the linker does is that it needs to link to one function. Okay, so that's super important. Like if I go in here, I can't do like another function. Another function like this here. Print header, even if it has like nothing in there, it's not the same function. Let's make sure it's closed. If I go in here and I compile. It's gonna, oh, you know what? The compiler is already catching that. The compiler is already catching that. But it's because it's the same file. If I was to move this into another file, so let's create another file here, a new CPP file, and let's call it other.cpp. And let's put in here that empty function. Now, if I compile, sure, the compiler has no problem because he compiled that one. He saw that, okay, yeah, there's no repetition. Those are functions are fine. And then he compiled that one separately. So there's no repetition in here. He's fine. But when the linker is actually going to run, he's going to come here and he's going to complain. So let's run it so that the compiler and the linker run. And there we go. We get that one. We go into the output and he's going to say, error linking, the return type void. And he say the declaration print header with void, and so no parameters, print header, already defined in case.obj. So obj is the type of file that is created by the compiling stage, and the linker use that type of file to link and create an executable. So he says, wait, it's already defined, and he's right because it's defined in here and in here. So whenever he comes here, he's like, okay, but which one are you actually looking to use? I can't tell, so he's going to throw an error, a linking error. Now, you've seen that probably, like if I change anything about this function, like not in that body, but in the declaration. So if I say like, oh yeah, but this print header returns a bool, then we're going to be fine because, oh yeah, because I don't return here, right? Is that what? Yeah, it's just because I don't return. Let's return here, return true. now he's going to be completely fine. You see, like it compiles, because whenever he came across my actual main.cpp, it was clear which one I was actually trying to link to. It was the one in case.cpp. So that's fine. So you can change the signature either here, either you change the name, or either you change a parameter. So if I would to say like print header, actually take int character count max, to say like I want to limit the number that it prints, number of character it prints, then it's the same thing. Like it's going to be clear to the linker which one you're actually trying to use. So the linker is actually the one that's putting all the files together, and then making sure that he can find the body for the function that you're trying to use, and that he can only link to one body per things you're trying per function or types you're trying to use. So you're gonna see like it's always like these two errors. So case the compiler errors, which means that if I have a compiling error in the CPP, it means that the error is strictly in that file. There's maybe syntax error, like a missing thing, or a symbol that he doesn't know about. So that means usually you're missing an includes. And you're gonna have the errors that start with an L on the output tab, that are linking error, which means like there's something wrong with the declaration of a function. Either still he can't find one, because it's going to be the same thing, right? I can like say here, and that's one thing with the compiler, I can say here void printer like this, and use printer, like let's go in here, printer like this, and I can use printer in here. And then like I said, the compiler is not going to throw any errors, because he says, sure, printer exists, you told me it exists right here. But then the linking stage is going to say, hey, I have an unfound symbol. I think it's the unresolved external symbol, meaning like I cannot find in any object file printer function that returns void, and it's called printer and has no parameter. And he's going to say its reference is main. This is kind of an internal ID that he generates. So when you read this, sometimes it can be a little bit overwhelming, but basically you see it's L. It starts with L, well, L and K, which means it's a linking error. It says unresolved external symbol. That's the symbol he's trying to resolve, which is a void that is declared printer void, with no parameter, and then it's reference in main. So usually you can go there, you're gonna say, oh, printer is here, yeah, I have the headers, I have the declaration for it, where's the body for that function? And then you can kind of fix that. And there we go. Right now we have kind of a small project, but it is much more clean, because we can put our function into separate files, we can put our declaration into separate files, and then we can have a main body that is cleaner. There's one other advantage I wanted to talk about with the headers. It's that, let's say here in a main function, I kept them here, okay? Let's say I don't use the header here, okay? We're gonna start. It's gonna be completely fine. Everything is working. But now I wanna create other here. And I want to use, because this is like just a wrapper, I want to use the print header, how is it called? Oh yeah, I'll call it the same thing, right? Print header right here. Oh yeah, I can do, yeah, I can do that. I want to do the print header here, okay? So here, first of all, he's like, the error he's doing is like, hey, there's too few arguments, because I'm in this file and I only know about one print header, and that's this one, and this one takes a character count. So, oh no, but it exists. I can declare here that it exists. I'm gonna do it there, void print header. There we go. We're fine, right? So this is gonna compile. Compile. There we go. No problem. But if I run it, we know what's gonna happen. Wait, in other here, oh yeah. The linker has no problem. In fact, it's just he knows about this, because like it's the linker has read about it in the case file here. But the problem you see is I have it here and I also have it here. So if I want to use also that function in that file, well, I need to copy paste this. And then I can use it. So you see that it gets pretty repetitive, and that's why also that's the main reason why we use those header file, because right now it's easier for me to go include instead of copy pasting it manually. It's easier for me to say to the preprocessor like, hey, whenever you read that file, just copy this in here for me, please, because this is way easier and way less verbose for us to actually work. And then there you go, we have no problem. There it is for our video on function headers and CPP files. So with this, you're gaining a better understanding of how to structure C++ project, and at the same time you're going to be able to read the code in an Unreal Engine game. There's still a couple things that we need to see before we actually jump into Unreal, but it's not that far. So that's the great news. We still need to see like how you organize like classes to do a more object-oriented programming that you're probably used to, and those pointers, which are a big subject that we're gonna see. I might add 1 or 2 optional videos on the compiler and the linker, because I've been like reading a lot about them recently, and it's been giving me a lot of insight on how an Unreal project or a C++ project is structured, and how Visual Studio also work. So I might include a video on that, but other than that, we're gonna jump after that in Unreal Engine. So if you like the video, please like, share, and subscribe. Thank you for watching, and I'll see you in the next video.